So we're doing chapter 7D and 7E, depending on how far we get. Now, last lesson, if you guys remember, we started looking into how to describe the correlation or the connection, or you could also say the, what other words did we use? Correlation, coefficient, association, all of this. Okay, these words here. So I'll actually write a few more. Relation, connection. Okay, they all mean the same thing. When we're asking you to describe the relationship, describe the connection, the correlation, the association, all of this, it all basically means the same thing, yeah? And when we're talking about that, what you're looking for, okay, is you're trying to describe these four different things. What's the direction? What's the outlier? What's the form? What's the strength? Okay, and in last lesson, we looked into what all of that meant. So direction is whether it's going up, which is positive, or down, which is negative. Outliers, are there any dots that don't quite fit the rest of the data, like that dot? Form, is it linear or non-linear? Linear means you can put a straight line through it. Non-linear means it sort of curves a little bit. Okay, it might curve down, might curve up. And then the strength is how close the lines fit together, or the points fit together, to make some sort of line. So the more close it is, the stronger it is, and the more spread out, the weaker it gets. Now, generally, you can make a call and look at a graph and describe it. Okay, you can describe just by looking at the graph what kind of strength, form, direction, or if there are any outliers. But now, what we're going to look into is, instead of just being able to look at it and say, oh, yep, it's strong, it's linear, it's positive, it's negative, or there's an outlier. Instead of that, we're going to now use an actual numerical value to determine whether or not something is strong, if it's positive, if it's linear, okay? And this is actually a lot more accurate because it will give you a definitive answer. Because sometimes if we looked at these graphs here, okay, some of you may have said, oh, sir, I think that's pretty moderate. Some of you might say, no, I think it's weak, okay? But now we're going to have an actual numerical value where we can tell what the strength is, or what the direction is, and all that. Okay, so assuming, normally when you're working with graphs, assuming that the graph is linear, okay, which means that there's no curve and that there's no outliers, then the strength in the direction, which is the association or the connection between two variables, okay, can be found using this word, correlation coefficient. So that is basically a numerical value, as it says here. So it's a correlation coefficient is a numerical value, and whenever you see the word R, or the R value, it's relating to the correlation coefficient, okay? So they're the same thing, okay? Remember that. Whenever the question says, calculate the correlation coefficient, it's referring to the R value, okay? Now, the R value, like I said, is that number that will tell you if something is strong, moderate, weak, positive, negative, linear, non-linear, or outliers or not, okay? So the correlation coefficient, that R value, can only ever be a number between -1 and the number 1, okay? So just remember that. It's a number between -1 and 1, and it's normally a decimal. You'll never really get a perfect correlation coefficient that's a 1 or a -1, okay? It's always going to be a decimal. So I'll put that here. Normally some sort of decimal number, okay? And the reason why it's -1 and 1 is because when you have a negative correlation coefficient, it's going to be a negative graph. What do you guys think will happen if you have a positive number? It'll be a positive graph, okay? So if it's a negative number, it's a negative graph, or it's going downwards. If it's a positive number, it's going to be going upwards, okay? So how do we then interpret it? It's the same as how we've been interpreting typically these, and describing these words here: direction, outlier, form, strength. Normally, outliers now will be irrelevant because, remember, in the first statement of this lesson, okay, if a graph is linear and there's no outliers, okay? So we're just going to essentially talk about the strength, the form, and the direction, those three things, when you're interpreting the R value. Okay, so you basically talk about strength, form, and the direction. Those three things. Outliers don't become relevant anymore. Okay, so here's what we talk about. Direction is easy, positive or negative. Okay, so if you have a positive number, it's going to be a positive association or positive direction. If you have a negative number, then it's going to be a negative association. So just look at your number, positive or negative. Okay, that's the first one. Strength. Okay, now this is where it gets a bit tricky. If you have an R value of -1, as you can see here, -1 implies that the line that the dots make is perfectly straight, as you can see there. Okay, it's perfectly linear. Okay, and it's going to be perfectly straight. Anything apart from a -1, so any decimal that's not -1 or a +1, that means the dots will start to look a bit more scattered. Okay, remember, that talks about the strength of it. An R value of 0 looks like this. Okay, you can see it's all over the place, which means that there's no correlation, no association, no relationship. Okay, no connection. An R value of +1, as you can see there, it's perfectly straight. Okay, and it goes in a positive direction. Okay, so you can see the difference again with a -1 and a +1 right there. One thing you can do is this is actually also in your textbook. Okay, you can actually refer to this as well. But if you have an R value that's between 0.75 and 0.99, that would be considered as a strong in terms of the strength. So if it's between 0.75, 0.99, it is strong. If it's between 0.5 and 0.74, then it is moderate. I'm just, okay, it's moderate. Okay, if it's between 0.25 and 0.49, then it is going to be weak. Okay, anything between -0.24 and 0.24 is going to be considered no association, because when you look at a graph that looks like this, it's probably going to look some really random like that. Okay, a bit too random to be able to tell what's the direction, what's the strength. Okay, it's really hard to tell. With a negative graph, so if it's between -0.49 and -0.25, okay, it's going to be a weak association. Between -7.4 and -0.5, it'll be a moderate, and then -0.99 and -0.75, it is strong. Okay, so just be aware of how those graphs will look like when you do them. I mean, I could draw simple ones for you here. Okay, for a strong graph, you might have something that looks like this. Moderate, these are positives. It's going to be a bit more spread out. Okay, and then for weak, it might look something like this. Notice how, remember, the strength tends to be decrease as the graphs decrease in the strength. Same with weak, okay? Same with this. So this will be a weak negative. It'll go in a downwards direction, okay, but it's very spread out. So it's really hard to tell. Moderate, the dots are a bit more together, but still pretty spread out. And then strong, they might be quite together to the point where you can tell that it makes a straight line. And then no association again, that's what that looks like. Okay, pretty straightforward. But now you might be asking, how do I get this R value? Where do I find this R number? This is where we now use a calculator. So please get your calculators out and we'll get them ready. But I'll show you real quickly how it's done right here. So calculating this R value, remember, correlation coefficient just means the R value. How do I find that R value? So this is what we do in a calculator. Typically, we know how to do this already. The first part is put your data in your calculator. So you've got your list and your spreadsheets. You've got column 1, column 2. Make sure you know as well which is your EV and which is your RV. Because if you get them the wrong way around, you're going to get the incorrect R value. So firstly, understand that. Label the columns as you know. And then you've probably seen this before. Menu, and then you press 4, which will give you the stats, press 1, which will give calculations, and then number 4, which would be linear regression. Now, these are actually shortcuts. So when I say menu 414, it's a shortcut on how to get to this, calculating your correlation coefficient on your calculator, okay? Well, let's do that on our calculators. So what I want you to do is we're going to work on question example A there. Put these numbers in your calculator. Okay, so put those numbers in your calculator and we'll get to finding the R value. So the question there is saying, find the correlation coefficient and describe the strength of the association. It only says strength, but let's include the form and the direction as well. Okay, so let's talk about all three. Again, they've put the EV on the top. We'll treat that as the EV and the RV as the hair length. All right, so on our calculator, in order to get the R value on our calculator, I'll just put my cursor up at the top for now. Just put it down here. Don't put your cursor here because it's not going to work. And remember when I said before, menu 414, you're literally going to press menu, statistics, so number 4, number 1, stat count, and then number 4, linear regression, A plus BX down here. So you press the number 4. And this brings this up. Okay, now this is why we need to understand which is EV, which is RV, because in the X variable or the X-axis is what you put in your EV. So we determine that height, so if you go back to here, height is going to be your EV. Okay, so let's put that as our EV, and then our Y-axis, a Y variable, is going to be hair. Okay, EV and RV. Always make sure you understand which is which. And now from there, you're going to get a bunch of different variables, okay? Now, there's a lot here that's happening, but what I want us to focus on for now is just the R value right here, okay? The R value here is negative 0.4, okay? So what does that mean? If your R value is 0.4, let's put that here. Actually, let me double check that. It's negative 0.4, okay? Okay, what does that mean? So how do we then interpret the connection for this? If it has an R value of negative 0.4, have a look at the this graph here. Okay, negative 0.4. Where would that lie? Well, that actually lies between negative 0.25 and negative 0.49. So what you can say about this is it's going to have a weak negative linear association. All right, so you would say, remember back to how we answered these questions. There is a weak negative and then also linear association between height and hair length. Okay, so that's how we would write down the answer for writing down the association, the connection, the correlation, all of that. Remember, means exactly the same thing. Okay, and you can also probably assume already that that's going to be the case because remember, there's no connection between your height and your hair length, okay? All right, let's do B, and then we'll start doing some work. So B, put that again in your calculator. Remember, menu, do it again, sorry. Put your cursor there, menu 414 for the shortcut. We go age, and we go YouTube for the Y variable. Okay, all right, and you can see that the R value is negative 0.83. All right, because we assume that the older you get, the less the number of YouTube videos you'll watch, which supports our idea because this is a negative R value, which means it's going in a negative direction. So if we do that, negative 0.83, okay, negative 0.83 for this, the R value, 0.83, negative 0.83. That's one thing that most kids do forget, and you can see that I do as well. Don't forget to put a decimal there. Let's make it 84, sorry, rounding it properly. Okay, so now let's describe the association. It's a negative. Okay, look at the number 0.84, a negative 0.84 falls between this variable here, so it's quite strong. So therefore, we do say now there is a strong negative linear association between, talk about the variables, age and number of YouTube videos. Okay, easy. And that's basically all we have to do when we interpret the R value. Okay, so just understand EV and RV first, put your numbers in, and you can use this little scale, okay, to figure out whether the strength is strong, moderate, weak, and what's the direction. And then use the R value to talk about that. Okay, that's going to be it for that.